For millions of years, Earth has been a suitable home for life, with a temperate climate and environment that has given rise to a phenomenon that has yet to be seen anywhere else in the universe. Simply put, a delicate balance has been struck, and it has given rise to something incredible as a result. But how much longer can that balance hold? Well, as it turns out, everything that has a beginning has an end, and in the case of the Earth, there are a lot of different and interesting ways in how the future, and its ultimate demise, could play out. Now, before we get into the metaphorical time machine, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so to start, what will happen in the next few million years? Simply put, not a lot. Human-caused climate change is expected to take only a couple 100,000 years to subside, even in the worst-case scenario, after which Earth will probably go through another ice age similar to what happened 10,000 years ago. Even if humans drove themselves to extinction some other way, like through nuclear war, it will probably only take a couple million years for biodiversity to recover, since even the worst mass extinctions in the past only really had an impact for about 5 million years at most. Beyond this, species will evolve and go extinct, continents will drift to eventually form a new Pangea and then break apart again, and the climate will continue to fluctuate through natural processes. It's not until we get to around 600 million years from now that something really begins to put pressure on life, and it all has to do with the gradual brightening of the sun. You see, the sun powers itself through the fusion of hydrogen into helium at its core under immense temperatures and pressures, and has been doing so ever since it formed 4.5 billion years ago. The outward pressure from nuclear fusion is able to counteract the star's own immense gravity, keeping the star in equilibrium. You see, as helium builds up in the sun's core over time, it is causing the core to slowly contract, causing it to increase the rate of fusion in order to maintain this fragile equilibrium. The end result is the sun slowly getting brighter over time, at the rate of about 1% every 100 million years or so. This, obviously, has the effect of warming the solar system over time, and in about 600 million years, it will have warmed Earth to the point where it begins to impact the natural processes of the planet. Specifically, as the oceans begin to evaporate, plate tectonics will start to slow down, and therefore less carbon dioxide will enter the atmosphere from volcanoes. This is important, since carbon dioxide is a critical part of photosynthesis in plants. Simply put, without carbon dioxide, plants will be unable to sustain themselves and will slowly go extinct, with plants that require less CO2 surviving for longer. This will start a domino effect, as plants are a vital source of food and oxygen for animals, so once plants disappear, it won't take long for animals to do so as well. Some species may evolve adaptations that may allow them to survive longer, like plants becoming carnivorous like the Venus flytrap, or evolving to need less water and oxygen. But by 1 billion years from now, with the sun being 10% brighter than it is today, Earth's average surface temperature will reach levels comparable to Death Valley during the summer. Needless to say, with the climate this extreme and the oceans rapidly drying up, it becomes next to impossible for complex life to survive. So from this point on, the only life that will exist is microbial life hanging on in hydrothermal vents or in slightly more favorable environments near the poles. The next couple billion years after this point are largely characterized by the sun continuing to get brighter, Earth getting hotter because of it, and the evaporation of the oceans. By the time you get to around 3 billion years from now, Earth's surface temperature rises to around 300 degrees Fahrenheit or 150 degrees Celsius, which is hot enough to all but guarantee the complete evaporation of all liquid water, and thus the extinction of even single-celled organisms. Now, one very interesting thing about the oceans evaporating is that it puts a lot of water vapor into the atmosphere. The thing is, water vapor is an incredibly potent greenhouse gas, even more so than carbon dioxide. As a result, if the oceans evaporate quickly enough, the immense amount of water vapor could combine with the sun's increased brightness to trigger what is known as a runaway greenhouse effect, similar to what is believed to have happened on Venus billions of years ago. As a matter of fact, it is possible that Earth may be subjected to even more extreme conditions than Venus has today. While Venus is currently subjected to temperatures around 860 degrees Fahrenheit or 460 degrees Celsius, due to the fact that Earth's greenhouse effect will be caused by water vapor as opposed to carbon dioxide, it is likely to reach temperatures exceeding 1800 degrees Fahrenheit or 1000 degrees Celsius, which would make it the hottest planet in the solar system. It may even get hot enough to partially melt the crust, so instead of oceans of water, we may be looking at oceans of lava. It is also believed that around this time, the moon will move far enough away from Earth that it will no longer have a stabilizing effect on its axial tilt, causing said tilt to begin to vary drastically and creating an even more chaotic influence on the climate. Finally, it is worth mentioning that during this period, there is a very slim chance that disturbances caused either by a nearby star passing by or potential uncertainty in the orbits of the planets themselves could cause Earth to either crash into a different planet or get ejected from the solar system entirely. In the case of the latter, it could get quickly recaptured by another star, which could in theory allow life to survive for longer, but the odds of this happening are estimated to be 1 in several hundred billion. The Earth is predicted to remain in a superheated greenhouse state until about 6 billion years from now, when the most dramatic and uncertain phase of its future is slated to begin: the death of the Sun itself. You see, around 5.4 billion years from now, the Sun will finally exhaust the hydrogen it has in its core. When this happens, the core will once again contract, and the temperature and pressure will once again increase. However, it is not at the point where helium can get fused into heavier elements. Rather, hydrogen will begin to fuse in a shell around the core, a process that will pump a tremendous amount of energy into the Sun's outer layers. As a result, the Sun will begin to slowly and steadily expand, slightly cooling in temperature, but eventually getting hundreds of times bigger and thousands of times brighter than it is today, a state known as a red giant. During this process, Mercury and Venus will almost certainly get destroyed, consumed by the expanding Sun. Eventually, the Sun will reach a radius about 250 times larger than its current radius, or in other words, about 20% larger than the radius of Earth's current orbit. You would think that it would be game over for Earth at this point, but the reality is quite a bit more complicated for one reason: the Sun will be losing mass like crazy. During a star's red giant phase, it has a stellar wind that is hundreds of times more powerful than when it's a normal yellow star. Since stellar wind is essentially plasma that is leaving the star, over a short time frame, this equates to a significant portion of the star's mass being lost to outer space. This, in turn, causes the orbits of the planets to expand, including Earth. Scientists still aren't sure what will happen to Earth because of this. On the one hand, if left unimpeded, Earth's orbit will expand about 50% to roughly where the orbit of Mars is right now, which would be more than enough to escape destruction. However, it is also possible that Earth will get caught up in the drag from the Sun's massively expanded corona, which would counteract the orbital expansion and lead to a death spiral where Earth gets incinerated by the Sun, approximately 7.6 billion years from now. Even if Earth doesn't get destroyed, however, the intense solar wind will strip it of its greenhouse atmosphere, leaving nothing but a lava world superheated to thousands of degrees and really leaving no trace of the lush green world as we see it now. At any rate, once we get to about 8 billion years from now, the Sun will have at long last exhausted all of its remaining fuel. Since it is not massive enough to fuse heavier elements in its core, it will not collapse in on itself and go supernova like more massive stars do. Instead, it will gracefully shed its outer layers in what is known as a planetary nebula, leaving behind a hot, dense stellar remnant where half of its present-day mass is condensed into a body only slightly larger than Earth is today, an object known as a white dwarf. With no fuel left to burn, the white dwarf sun will slowly radiate away its remaining heat, a process that is expected to take quadrillions of years to complete. In the event that Earth survives the red giant phase, it too will rapidly freeze over as the white dwarf will provide pretty much no heat and light at its greatly expanded distance. Over extremely long time scales, it is likely to be ejected from the solar system by a nearby star, or stellar remnant, or if this doesn't happen, its orbit will slowly decay until it collides with the Sun, which by that point will have cooled to near absolute zero. So yeah, the future of Earth is, all things considered, pretty bleak. The good news is, however, that the timescales involved here are orders of magnitude greater than that of the human lifespan, so there really isn't a need to worry about any of this happening anytime soon. For now, we just need to make the most of Earth in the time that we have, and let's not try to make it a hellscape ourselves while we're at it. As always, I would appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks, and have a great day.